So in chapter 7, we're going to talk about telecommunications, the internet, and wireless technology. So for organizations, some of the trends in telecommunications include the fact that instead of having two separate types of networks, voice networks and data networks, which is the way that organizations have set up their networks in the past, there's this convergence of networks. Organizations, you probably see it as a consumer, telecommunications companies like Verizon, Sprint, AT&T, when you go to get residential internet, they try to bundle everything together. They want you to get everything with one company, your television, your internet, your landline telephone if you have it. So companies are actually seeing this convergence also, and a big part of this is because voice data is moving away from our regular telephone lines and actually moving toward voice over IP, where you're sending voice over regular over data lines. It's being sent just like any other type of packet. And we'll talk a little bit about packet switching and the internet. Okay. Broadband is becoming more and more accessible to individuals as well as organizations. Over 60% of the households in the U.S. have some kind of broadband access. And that broadband is anything that's not dial-up. So cable, internet, DSL, satellite, fiber optic, all of those are broadband internet. We also have a lot of people that are connecting using different wireless devices. Mobile devices in particular are actually one of the #1 ways that people connect to the internet. People have their smartphones, they go on to do a quick Google search, to fill out a form, to do something else, find out information very quickly and easily using their mobile devices. So let's talk a little bit about what a computer network is. A very simple computer network is just two computer devices that are connected together. Okay, so it's two or more devices connected somehow, whether they are connected wirelessly, they're connected using an Ethernet cable, some other wired connection. Most simple networks have some particular major components in them, a client and a server computer, and we'll talk about what client-server computing is. A network interface device, which is actually connected to every computer device. Every computer device that's connected to a network has a network interface card on it. Okay, so all of your laptops, your smartphones, all of them have network interface cards in them. Otherwise, they wouldn't be able to connect to any kind of network, wired or wireless. Okay, there's usually some connection medium, whether it's wired, it's Ethernet, telephone line, some other type of medium to connect. A network operating system is going to be on one of the devices that is connected, that creates this network. And some kind of hub or switch, which actually controls the communications and packet switching that happens in the network. Okay, a router is a device that routes the different packets through different networks. So to connect to the internet, you have to have some kind of router to get you kind of out to the internet, unless of course you're connecting using the cellular network. The iPads now, you can buy iPads that connect to the cellular network. Your smartphones connect to the cellular network. Otherwise, you need some kind of router. So no matter what kind of internet connection you have, if you have an internet connection at home, you're going to have a router that actually controls the traffic, the internet traffic coming in and out of your network. Okay, and this is a simple network, a visual of a simple network. You have one or more physical devices that are connected to. A lot of times they're connected to a router, which is with these devices connected to one another if it's a home network. You might have a server connected. Not everybody's going to have a server, but every device that's connected on this network has a network interface card on it. You can have printers that are connected to a network so you can share printing. They also have a network interface card embedded in them to enable them to be connected to a network. Now, networks in large organizations are a little bit different, as you can imagine. Most of these types of networks are hundreds of local area networks, which are these smaller networks connected together using some kind of wide area network. Okay. A lot of times these types of networks have various different types of very powerful servers connected to them, servers that control and give access to their website, their internet and intranet and extranet, and then any back-end systems that they might have, their database, other applications that are available, other types of functional area systems, you know, payroll, operations, stuff like that. They might also have, you know, mobile wireless local area networks, video conferencing systems, telephone networks, and other types of wireless cell phones. So this is a visual of a possible typical corporate infrastructure. Again, where you have different types of servers for the website and other types of resources that the organization has. Wireless local area networks or other wired local area networks. And again, a lot of these networks are a lot of small local area networks connected together using some kind of larger backbone, a mobile Wi-Fi network, and then of course some kind of voice setup. Okay. Some of the key technologies that support telecommunications and networking include client-server computing. Now, client-server computing is basically, you know, a very simple client-server network is a client machine. All of your guys' mobile devices that connect to the internet are client machines. When you open up a browser, you connect to the internet, you're requesting a web page. You are connecting using the internet infrastructure to a server. It could be Google server, it could be the servers here on campus to get to Blackboard. Any of those things, those are all servers. So you're a client connecting using the internet to a server. Okay, but the server usually sets the rules for that type of communication in a client-server network. And this type of network has replaced that mainframe network. I know that in chapter 5, I think it was, we talked about the different stages of computing and how mainframe networks were a big thing back in the 70s and the 80s. The internet is the largest implementation of a client-server network. So the internet is a huge client-server network. It's all a bunch of clients and servers connected to each other. Okay. Packet switching is another technology that's very core to the internet and to all of the technologies that utilize the internet as a medium. Packet switching is this idea that all of the data that gets sent using over the internet it all gets chunked up into pieces called packets. Everything's a bunch of packets. So pictures of my dog that I'm uploading to Facebook and your financial information, it's all packets that are sent using the internet. The way that the internet operates now, there's no precedence for no data has any more importance than other data. So again, your medical record data that's being transmitted is as important as as my my pictures of my trip to Hawaii or whatever. So it's all just packets that are being sent over the internet. That's one of the reasons why if you use voice over IP like Skype in its early implementations, how it was a little bit hard to understand. Sometimes it would skip. It had some issues because it's not it's not a real-time type of connection, and because those packets are going through the internet. And if we take a look at, I have an image of packet switching that I thought was kind of nice because It's kind of an animated image, but it's basically when you're sending packets, it's showing packets 1, 2, 3, going from one computer, from A to B, basically, that they don't follow each other like a train going through. They go through and try to find the fastest way from A to B at that given time. And the thing about the internet that I think we talked about as far as security concerns is that every computer, every router that's connected to the internet is helping to send packets that don't belong to that router. So that's why there's security concerns with sending data over the internet, because it's an open infrastructure. You're sending your data using other people's computers, other people's routers, and because of that, there's the possibility that it could be changed or it could be intercepted. Okay? Okay, and this is the image that your book gives, but again, it's the same type of idea, where you have one message that's cut up into pieces. Here, it's 3 different packets, and again, they're just trying to find the quickest way from A to B. Once it gets to the other side, the message is reassembled. Okay, packet switching replaced circuit switching, which is what our regular telephone line is. And circuit switching is a little bit different. With circuit switching, you had to make the connection, point-to-point connection between 2 devices before communication could happen. So you think about your telephone calls. When you call somebody, you dial their number, you make that connection, and until that connection is made and the 2 devices are connected to one another, there's no communication happening. Okay, that's called circuit switching. Packet switching, you don't necessarily have to have those 2 devices connected in a point-to-point basis. You're sending packets using the open internet. So it's actually a much better use of resources versus that one-to-one type of connection that circuit switching requires. Okay. Other key technologies include TCP/IP. TCP/IP, the Transmission Control Protocol, Internet Protocol, is 2 of the major protocols that the internet is based upon. And again, protocols are rules for communication governing how 2 or more devices are going to communicate with one another. TCP/IP was developed by the Department of Defense as a part of the internet itself. The internet was actually a network that was developed by the Department of Defense back in the 60s, I believe, 60s or 70s, as a means of communication, an alternate means of communication in times of disaster or war or other things. That was actually the main intent at the beginning of the internet. Okay. TCP/IP itself has 4 different layers according to the model that the Department of Defense has come up with. I've seen other models that have up to 6 layers, but the one that we talk about here has 4 layers. The application layer, the transport, internet, and network interface layer. And each one of these layers, when you're sending, you can kind of imagine 2 different devices, again, 2 different devices communicating with one another, sending an email message that gets cut up into packets and sent over the internet. That email message, each of those packets has to go through each one of these layers before it gets to the internet, and then back up through those layers to get to the email client to be reassembled into an email. Okay. At each one of these layers, application, transport, internet, and network interface, you have layers of information that is added to the packet, to each packet. So you can imagine when you send a message, you send a letter using, our regular snail mail, post mail. There's certain things you have to have on that letter to make sure that it gets from A to B, right? You have to have an address of where it's going to, right? A full address. If there's pieces missing, it might have trouble getting to where it's supposed to be going. You have to have postage. You have to have an envelope to cover that information. So you can kind of imagine that as the packet is going through each one of these layers, there's a piece that's being added to it. It goes to the internet. It's basically addressing that packet so that we know that it's packet 1 of 6, and it's going from this computer to that computer, so it gets to where it's supposed to be. It gets to the recipient, okay? And then, of course, as it's going through each one of these layers back to the recipient, those pieces are being taken off at each level, so that at the end you have just the packet, okay? When we talk about circuit switching versus packet switching, circuit switching, you know, the best example of circuit switching is your regular telephone, your actual landline telephone lines. The signal that your landline telephone, your telephone lines use is called an analog signal, okay? And this analog signal, right, if you were to actually look at maybe my voice as I was talking, right, you would actually see fluctuations in the pitch of my voice and how loud my voice gets. You'd actually see a lot of different individual points. And analog signals have a multitude of different possible data values, okay? And so when we're sending data using DSL, right, your DSL signals, they actually still use your regular telephone line. You're sending digital data, which all of your computer devices all use, you know, 1s and 0s, binary data, right? You're sending binary data over a medium that is analog, okay? So there has to be this translation that happens from your digital, your 1s and 0s, to actually analog waves, okay? And your modems are the ones that do this. If it's fiber optic, right? It's going from digital. What type? Do you guys know what type of data fiber optic cables send and receive? Sure, it's light waves. Fiber optic, kind of think of, have you ever seen those fiber optic Christmas trees that have all the little lights and stuff? It actually sends light waves. So you're doing a translation from 1s and 0s to light waves. It's basically either light or the absence of light to represent a 1 or a 0. But again, you have a modem that is doing that translation to send digital data to translate it into the type of data that the medium actually accepts. Okay. Now there's different types of networks. I talked a little bit about local area networks. Local area networks are small networks. When I say small, you're usually looking at a building or a floor or an office. The small networks that you create at home, those are all local area networks. When you get past about a half mile to a mile, you're looking at, they have these campus area networks, which, to be perfectly honest, this book is the first time I've heard of a campus area network. Although I'm sure it's, you know, it's a real thing, they wouldn't mention it if it wasn't. But this campus area network, they talk about this as an intermediate network in between a local area network and a wide area network that has a radius of about a mile. So campuses, you know, about a mile, maybe a little larger universities, they can actually have an intermediate type of network in between a local area and a wide area network. You have peer-to-peer networks, which again, when we talked about this client-server type of network where you have the client connecting with the server to request resources, a peer-to-peer is actually two clients connected to one another. Okay, so there's no server in that mix. When we have different types of local area networks. There's 3 different types of topologies, and we'll take a look at each one of those and talk about those in a little bit more detail. And then, of course, your metropolitan area networks, which a metropolitan area network is a network that covers an entire city or metropolitan area. Over here, the city of Riverside has a metropolitan area network. They actually have free Wi-Fi internet anywhere in the city of Riverside, not the county. So if you're actually in, you know, Riverside proper, the city, there's free Wi-Fi. It's not, from what I know, people who live in Riverside, it's not the fastest connection, but if you just need to get online, you need to check your email, it will suffice. I believe Philadelphia is another city that has implemented free Wi-Fi for the entire city. And then of course wide area networks, and the largest wide area network, you guys know what the largest wide area network is? It's the internet. So a wide area network is pretty much everything else that's not a metropolitan area network or one of those local area network. Everything else globally, all of these other very large networks are all wide area networks.
Going back to the LAN network thing, would that reference like when you're at work and you have like your LAN IDs and stuff like that? That would be the peer-to-peer?
They're a little bit different. Local area networks aren't necessarily peer-to-peer. A peer-to-peer means there's no server in there. You have clients that are connected to one another. So you, when you think of peer-to-peer networking, you think about Napster and some of the other types of third-party. Napster, and I'm sure there's a few other, I can't think of any of the other current ones. I don't think Napster, I don't even know if Napster exists anymore. What?
Torrent?
BitTorrent? Yeah, I think that's the other one. It's basically a third party that allows clients to connect to one another and to download and upload resources from each other. So that would be a peer-to-peer network, which is a little bit different because there's no, you're not connecting to a server, you're connecting to another client. But yeah, if it's a small network, a building or a floor, it's probably a local area network. So and if it's a local area network, there's a server in the mix somewhere, basically controlling the network. Okay. So the three different types of topologies that are out there. You have the star topology, the ring, and the bus topology. And these are all different ways of, basically different ways of setting up a local area network. Okay, the bus topology is where you have two different stations, one at each end, and only one of these stations transmits data in two directions. Okay, the ring topology, you have data. It's sort of a, it's obviously a ring structure, but there's no end to it. So you have data that goes in one direction. It's not bidirectional. And then the star topology is where you have one central, usually some kind of not a router, some kind of hub that connects all of the different parts to the network, and all of the traffic in the network has to go through that hub. Okay. The most common type is actually the bus topology, as far as the way that most local area networks are set up. But again, it kind of depends on who's setting it up and if they have a favorite topology, or there's something they're more familiar with. Okay. Physical transmission media. We'll talk a little bit about wireless connections, but physical transmission media. You have twisted wire, twisted pair, which is basically sets of 4 different wires, and each one of them are paired off and they're twisted around one another. They do that to reduce the amount of noise in the connection. So if you have any kind of interference in a connection, it can degrade the signal, and a lot of times that's called noise. Coax cable. Anybody know what you typically use coax cable for? Your cable internet. I mean, just your cable connection, your regular cable connection. Comcast, Time Warner, all of that. They all use coax cable. Okay. And then fiber optic and optical networks. And again, fiber optic is light waves, and actually the medium itself is. If I remember right, it's like pieces of glass that are in there. They're actually inside the physical medium. Okay. For wireless transmission, microwave is used a lot by satellites. This is actually kind of shows you an example of a satellite system that is used. Now, there's a couple of things about microwave transmissions. Microwave transmits at high frequency. They're radio signals, and they're used for high volume, long distance, point-to-point communication. The thing about microwave transmissions is that they follow a straight line. So microwave is actually like a line of sight type of transmission, and because of that, it doesn't actually bend to the Earth's curvature. So it won't actually kind of bend around the Earth's curvature. So you have to have the microwave transmission, the ones that are actually earthbound. They have to be about 37 miles away from one another. Any further than that, and they don't have line of sight. They won't see one another, and they won't be able to transmit any data. Okay, but satellites use microwave transmissions. And then, of course, there's the cellular telephone, the cellular network and we'll talk a little bit more when we talk about wireless. We'll talk about cellular networks. Now, transmission speed. We talk about transmission speed a lot in hertz, and hertz is a number of cycles per second. So when you talk about gigahertz, you're talking about thousands of cycles per second. Bandwidth is the number of possible, the range of frequencies that can be accommodated on a single communications channel. Okay, so those are usually the way that that network speed is measured. Okay. So now, when we talk about all of these, we talk about the network in this sort of abstract way, but really, what is the network? It's this extensive public communication system. It's so extensive that it now rivals, the public telephone network that used to be kind of the largest global network. It now actually rivals that. Okay. Now the way that the internet is set up, it has this addressing and architecture. Okay. Domain names. There's this whole domain name system, and domain names are English, are text-based names that are really the only reason we have the domain name system. Google.com, Amazon.com, all of those websites. Those domain names. Those really are for our benefit as individuals, as humans. The actual what the internet actually uses are these IP addresses, these dotted decimal addresses. So let's take a look at a list of some of the IP addresses of Google. Okay, you should actually be able to put in any of these dotted decimal IP addresses and actually get Google.com. Okay, they own a whole host of them because they have an awful lot of web traffic that they have to accommodate, right? But when you put Google.com, you could be connecting to any of these dotted decimal IP addresses. Okay, but really, if you had to remember 74.125.225.225, it's so much easier to remember www.google.com or www.laverne.edu. Right? So the domain name system, these English, the text-based phrases and words, that's all built for us as humans because it's so much harder to remember all of these numbers. If we had to remember a whole bunch of numbers, it would be not impossible, but it would be much harder. Okay? So, we talk about, it's a very hierarchical structure itself, and we can talk about these different levels of domains, okay? These top level domains, the .com, .edu, .gov, those are actually controlled by a third party. So when you purchase a domain, you're actually purchasing a second level domain that connects to a top level domain, right? So you can go online, you can go to GoDaddy.com, and you can connect. Let me see. Somebody give me a phrase.
Like a word?
Sure.
Dog.
Dog. I guarantee you dog.com is going to be taken. All of the really simple words tend to be taken. So, let's see. Oh, some variations you might consider: canine, canine therapy, comfort. It kind of depends on what type of dog service you're looking at. Dog.co.info.net.org, they're all back ordered. Actually, dog.anything, it seems like, is back ordered. But they have other domains that you might consider. Dog.com.ag, if you add something else on the end. Some of these are, they're back ordered, which basically means that there's other people in line trying to, to wait for that particular second level domain. Okay, so if you decide you want to open up a business, you're going to start a business, one of the first things you should do is to make sure that you can get and lock in your domain name, so that if you want to have a website, you have the domain name already ready to go. Okay, but yeah, so this is the structure of, basically the structure of the internet. When you purchase a domain name, you're purchasing these second level domains. Okay, these first level domains. What type of organizations are .gov? Do you guys know? Government, and particularly it's U.S. federal government. Okay, .edu. Education. It's usually some kind of education. Okay, so like .gov, you can't go on to GoDaddy and buy a .gov. Right? Those ones are, you have to be a U.S. federal organization. Right? And of course you can have these third level domains, and a lot of times the third level domains are different directories within a particular website. So sales.google.com, right? That's a subset of the google.com domain. Okay? There's no formal management for the internet. There are some standards bodies. The ICANN, W3C, IAB, those are all standards making bodies for the internet, but there's no, formal oversight of the internet. It's just kind of a collection of these standards making bodies. Now, the future of the internet, IP version 6 is one of the concepts that that comes into play, because just like phone numbers, what happens here in Southern California when we run out of phone numbers? They create a new area code, right? They split it up, they create a new area code, and you kind of double the amount of phone numbers you could possibly have, right? Well, IP version 4, right? You can have a total of 4,294,967,298 possible IP addresses. And obviously we're running out of addresses as of now. So they're looking at moving to IP version 6, which instead of 4 sections of dotted decimal addresses like Google over here, right? We have 4 sections, 72.14.255.255, that's 4, right? They're looking at having 8 of those. So actually these IP addresses will get twice as long, okay? But when they do that, you add, and I'm not even going to try to pronounce that number, but that's how many possible web addresses you can have if you move from IP version 4 to IP version 6. Okay, so this is one of the issues that, this is IP version 6 is on the horizon, because we are running out of IP addresses. Okay, Internet 2 is a high-speed internet that right now there's certain companies and universities that are testing it out, but it's sort of on the horizon again. It's basically a research project right now until it becomes reality. Now we can look at internet network architecture, right? This is possibly a typical organization or a typical internet, a section of the internet where you have different networks that connect to different internet service providers, and these regional hubs, connecting them to the internet backbone, which is basically the global connection, that the way that we connect large distances is this backbone, okay? Some of the services that are provided using the internet, a lot of these you're probably very familiar with. Internet chat and instant messaging, which has kind of gone beyond, chat rooms to become something that organizations are using quite extensively. A lot of organizations have implemented chat in their customer service infrastructure. You have news groups, which are basically, news groups is another name for discussion forums. It seems like if there's an issue that you run into using some kind of technology, a product, you should be able to Google or search for the error message, the issue that you're having, and there's probably a good chance that somebody's posted somewhere on a discussion board, and that you'll find an answer to your question. Telnet is the service where you log into one computer and you work on another. So it's basically the idea of remotely logging into another computer. File transfer is FTP is the protocol for uploading and downloading files. The World Wide Web is actually, we use the World Wide Web and the internet interchangeably, but the World Wide Web is actually a service on the internet. Okay, and so any website that starts with www is part of the World Wide Web. Okay. Voice over IP, we've talked a lot about voice over IP, which is again sending voice data using the internet, and virtual private networks. Virtual private networks, and actually there's a nice way of looking at kind of a visual for virtual private networks. Virtual private network is using the internet infrastructure, but creating this virtual point-to-point network. So instead of, it's cheaper than actually having a point-to-point connection between A or B, but it adds some levels of security that you don't get if you don't use a VPN. Okay, so, and here some of those, the different types of protocols, right? Domain name, FTP, simple mail transfer, SMTP, which is a protocol for sending and receiving certain types of mail. You can kind of see, some of the, some of these different protocols and where they kind of they show up. And then this talks about a little bit about, this kind of shows you how voice over IP works. And again, voice over IP is just another service, another set of packets that are sent using the internet. So voice over IP services have gotten to be a lot better. You don't actually hear some of the sort of like breaks in the conversation or things like that that you used to hear. But you are sending and receiving packets over the internet just like any other type of data. So you could possibly have interruptions in your service or slow packets or things like, packets that get lost, stuff like that. So when we talk about this kind of global internet, again, the World Wide Web is a service of the internet. On the World Wide Web, we have HTTP is the protocol that the World Wide Web utilizes, and again, the protocol is that set of rules for communication. Okay, HTML, hypertext markup language, is basically the way that web documents are formatted to be viewed on the internet. URLs, which are the web addresses of web pages. Okay, when you talk about these addresses, that's a URL, Uniform Resource Locator. And then, of course, web servers, and we talked about web servers pretty extensively. Okay. Search engines, you know, the first search engine was conceived in the early 90s. Relatively simple keyword. Search engines started out as keyword searches, but they've gotten to be a lot more sophisticated. Okay, and search engines are actually one of the major sources of revenue on the internet. Okay, there's software called shopping bots that are out there. That basically search the internet for shopping information. There are examples of this. Google has their own shopping bot called, I think it's like Google Product Search or something like that. Or they actually have a search just for shopping. When you put in, you go to Google. If you look over here off to the side, there's one right here that says shopping. So if I were to put, you know, right, Vizio is actually, Vizio is a piece of software. I click over here on shopping and it actually will pull up shopping products, basically do a product search for me. Okay, that's an example of a shopping bot. Okay. This is a nice visual way of taking a look at how Google actually works. Right, you put in a query, right? It sends that query to one of Google's many web servers. They have hundreds of web servers, probably thousands. Actually, the request is sent to their index servers, which actually are where web pages are described, and then they use their patented PageRank algorithm, which looks at, it measures the importance of a web page, so it goes beyond how many times does your keywords or your search show up on the web page, but it measures things like how many other web pages connect to that web page, right? Because the more blogs and other web pages that connect to that web page and basically see that page as a source, the more important it must be. So that's like one component, but it actually has 500 million variables that they measure web pages on using this algorithm to give you, to come up with your, your set of results that are delivered, and they're delivered 10 to a page. Okay. So currently, the top web search engines, right? Google, still quite popular. Yahoo, Bing, Ask, and then there's a little 10% here that's like basically everything else. Okay. And we talked about Web 1, this idea of Web 1.0 versus Web 2.0. We can revisit it again, but Web 2.0, if you recall, some of the features of Web 2.0 is that it's very social. There's a lot of interactivity. You have this two-way communication between the client and the server. There's a lot of user-uploaded content that is available. And there is some of this real-time user control. Okay? Some of the technologies behind Web 2.0 include things like cloud computing, which we've talked about a lot, blogs and real simple syndication or RSS, mashups, wikis, and other types of social networks. These are all Web 2.0 tools. Okay? Web 3.0 is an attempt to give meaning to the internet. So instead of just searching for keywords and looking for those when you do a search, actually going beyond that, giving meaning to the, the internet, kind of to a certain extent asking why. Beyond just what is out there, asking why. It's a huge endeavor, but basically it's trying to make web searches a lot more relevant to the user. Okay, so it's again, it's just like IP version 6 and Internet 2. It's kind of one of those things that's out on the horizon and they're working on. There's other visions for the internet, including things like 3D web, this pervasive web, internet that's everywhere, ubiquitous connectivity between devices, making the web a more seamless experience, and you have all of the major hardware and software companies that are working on, these different versions of what they see the internet and the internet experience should be in the future. Okay? Now, when it comes to wireless connections, and really wireless connections to the internet are some of the most popular connections. Most people globally get their information using a mobile device, some kind of smartphone, because it's so much more affordable to get a smartphone and connect to the internet versus actually getting a computer and connecting to some kind of Wi-Fi or landline connection. Okay, so there's two different standards, if you didn't know, two different standards for a cellular service: CDMA, which is basically just the United States, and GSM, which is the rest of the world, including AT&T and T-Mobile. They're creating devices, smart devices now, that actually are compatible with both of the standards, because you end up, if you have Verizon or you have a company that uses CDMA and you decide you're going to go travel and use your device, it may or may not work, because that's not the standard that is used outside the US. So you end up having issues like that. Third generation networks, 3G is what we're currently, a lot of us currently are. 4G, entirely packet switched, much faster, probably about, from what I hear, about 4 times faster than 3G, if it's true 4G. Other types of wireless connections include Bluetooth. A Bluetooth connection, you guys probably know how Bluetooth works. With Bluetooth, you have to pair devices together. They have to see one another. They have to accept the connection. Bluetooth works really well for personal area networks. You have a smartphone or a phone that connects to a Bluetooth ear set, or you have other devices that connect wirelessly to one another. Bluetooth has distance limitations to it, so you have to be relatively close to a 10-meter area, relatively close to connect. And then, of course, Wi-Fi, and there's a whole set of standards here for Wi-Fi. 802.11g is the current standard. A and B, that if you have A and B, basically when you purchase a wireless router, you'll be able to see one of the standard that it's using. If your 802.11n is the fastest current standard that's out there, but you're going to pay more for that type of router. G is the current. You probably won't go to Best Buy or another computer store and find 802.11a or b. Those are very old standards. They're still out there, they still work, but they're very slow. Okay, it's used for wireless local area network and other types of network. You have wireless hotspots. Those are all using Wi-Fi. Okay. Now this is an example of a possible Bluetooth network, right? Different devices that are all within a small area connected to one another. There's printers out there that use Bluetooth technology that you can pair with other devices to receive, signals and data. Okay, but this is just one example of different types of devices, and again, it's good for personal area networks, particularly because it's in a small distance. Okay. This is an example of an 802.11 wireless local area network, and again, you have this wired connection here that has an access point that is connected actually physically connected to the local area network, and it allows other devices to wirelessly connect to that same network. Okay. And we talked a little bit about Wi-Fi. WiMAX is actually gives you much larger range as compared to Wi-Fi. Wi-Fi, you're looking at half mile, if even that far. WiMAX, typical WiMAX, the range is about 31 miles, average range. Okay, you have some that'll go farther, 50 miles, right? One WiMAX access point to cover a 30-mile radius or a 50-mile radius. So it's it's the future of Wi-Fi, really. Sprint actually is building their 4G networks using WiMAX. Okay, it's expensive technology, but it's sort of the future of moving away from all of these small access points to one access point that will cover a much larger area. RFID, radio frequency identification, is used quite often for supply chain and inventory management. One example, actually, let's see, there's two different types of RFID. You have active RFID. These tags they actually have a battery in them because they need their own power source. They can be rewritten, so these tags are more expensive, but they actually have a lot more possible use. The passive RFID tags, they don't need a battery. They use the RF signals to power them. Their range is much shorter, but they're much cheaper. So, and when we say cheaper, you know, your active RFID, you're probably looking at a couple bucks per RFID. Passive RFID, you're looking at a few cents, right? So if you're looking at using it extensively for inventory management, right, you have to think about those prices, you know, multiplied by all of your inventory, all the use. And again, some of the automated uses, RFID is used quite extensively in supply chain management, inventory management. The toll collection, the 91 toll lanes, is one example of RFID technology. So if you use you know, the 91 toll lanes or the express lanes, right? That's an RFID chip that's embedded in this thing that sits on your in your windshield, and when you pass through and it charges your account, you're passing through an RFID reader. Okay, so this is basically how RFID works. You have an RFID tag that is emitting radio waves. It gets close enough to an RFID reader. The reader connects to some kind of system that reads the data for inventory management instead of, now RFID tags replace regular physical scanning tags, regular UPC tags. Because you just have to pass, if you're thinking about inventory management, each piece on the, each individual item has an RFID tag versus a physical UPC that you have to scan. All you have to do is go move the whole pallet through by an RFID tag reader, and it takes inventory of everything, you know, right then and there, instead of having to physically scan each UPC code. Okay. Wireless sensor networks. These are networks that have hundreds of thousands of interconnected wireless devices. They have built-in storage, processing, and radio frequency sensors and antennas. They require low-power, long-lasting batteries, because usually when you set up these wireless sensor networks, you set them up to be used for a long time. You can use them for monitoring building security, detecting hazardous substances in the air, monitoring environmental changes. So you might put them, these wireless sensor networks are used sometimes in agriculture, where you want to take readings of, you know, of the environment that you have, you know, you're growing plants in, that type of thing. And this is an example of a wireless sensor network. And again, it's all of these networks, all of these sensors that are connected to one another in a network fashion and are sending information to the system.